How does Python tuple immutability affect memory? Imagine having a box that you can fill with items, but once sealed, you cannot change what's inside. That's similar to how tuples work in Python. When you create a tuple, its size and content stay the same. This feature impacts how Python manages memory in several ways. Since tuples cannot be changed after they are created, Python can store just one copy of each tuple in memory. If you assign the same tuple to multiple variables, they all point to that same memory location. This sharing saves space because Python does not need to create multiple copies of the same data. Another benefit is that Python can allocate a fixed amount of memory for a tuple when it is created. Because the size and content are known and unchangeable, Python does not need to resize or reallocate memory later. This makes handling tuples faster and more efficient compared to lists, which can grow or shrink dynamically. Copying a tuple is also simple and memory-friendly. When you assign a tuple to a new variable, Python just creates a new reference to the same memory location. It does not duplicate the data itself. This means that creating multiple references to a tuple does not increase memory use significantly. However, it is important to remember that while the tuple's structure is immutable, the objects inside the tuple can be mutable. For example, if a tuple contains a list, you can change the list inside the tuple. This can cause indirect changes in memory because the mutable object inside the tuple can be altered without changing the tuple's overall structure. In practical terms, tuples are great for storing fixed collections of data that should not change. They are often used as keys in dictionaries or elements in sets because their immutability makes their hash values stable. Their fixed size and memory efficiency make them ideal when you need a lightweight, read-only container. To sum up, Python's tuple immutability affects memory by allowing shared references, fixed memory allocation, and efficient copying. It also means that if mutable objects are inside a tuple, changes can happen indirectly. Knowing this helps you decide when to use tuples instead of lists, especially when you want to save memory and keep your data safe from accidental changes.